Today's lesson deals with using angles formed by parallel lines and transversals. Basically, it's the same kind of topic from yesterday, just adding a tiny bit more information. So it's using the same terms from yesterday, just adding a little bit more. First thing you got to understand is if two parallel lines are cut by a transversal, then the pairs of corresponding angles are, and they tell you, congruent. Good. This occurs only when you have parallel lines. Did we have parallel lines yesterday? We didn't. I said they were kind of parallel. They looked parallel, but they didn't have the marks. They did not have the arrows that we now have. Therefore, they were not parallel yesterday. Today they are. And you can look. Do these look to be the same size? Definitely. You could draw one and slide it down and fit right inside the other. Pretty simple. Up next, we have identify congruent angles. So this uses some of the ideas about vertical angles and linear pairs too. So we should be able to fly through this kind of problem. First up, it tells you the measure of three of the numbered angles is 125. We need to identify the angles and explain your reasoning. So obviously that one right there is 125. It's obtuse. Write the word obtuse out to the side. Point to that one, write obtuse. What other pictures or what other angles in the picture are obtuse? Angle 1. What else? 7 and 5. 1, 7, and 5 are the other obtuse angles that are the exact same size. And they are only the same size because those parallel lines. Make sure they have those parallel lines. Without those, you can't say that. So 1, 5, and 7 are also 125. Pretty simple question. Go down and try the checkpoint real quick. It says if measure of angle 7, 75, find angle 1, angle 3, angle 5. Tell what postulate or theorem you used. Oh, we didn't explain our reasoning here. Why is 1 125? It's not given. It's vertical angles, which I heard some of you say. Good job. Some of you said given, not quite. But why is 5, which is over here, why is it the same as 125? They are not corresponding angles. They are alternate interior angles. These are words from yesterday. Alternate interior angles will be the same size. Why is 7 the same size? That's corresponding. Write out the word please. Good job. Once again, I'll give you a little bit of time on this checkpoint, see what you can do. So if you understood your terms from yesterday, today should be easy. Once again, today it says find 1, 3, and 5 if you know angle 7 is 75. I'll write angle 7 is 75 right there. I got to find the other ones which are the same size. I think the easiest one is right across from it. Angle 5 is also 75. Why can I say that? Okay, so measure of angle 5 is 75 degrees because vertical angles. That should be the easiest one out there. But we still need to find angle 1 and angle 3. Measure of angle 1 and measure of angle 3. Angle 1's way up here. Is it going to be the same size? Are they both acute or are they both obtuse? Both acute. That means they're going to be the same size. So angle 1's also 75. But why? Okay, yeah, that's a good job. Here's the transversal. Are they on the same side or different side of the transversal? Different sides. That means alternate. And are they on the inside of the parallel lines or on the outside of parallel lines? So alternate exterior. Last one is angle 3. Angle 3 is right here. How does it compare back to angle 7? Those are corresponding. They're actually on the same side of the transversal in the same position on different intersections. So they're both 75 due to corresponding angles. Good job. This real quick is a review of yesterday. Identifying these positions. These are in what position? Those are alternate interior, and it tells you that. The key thing you need to understand is that they are congruent, which is noted right here. The next one right here, what location are they in? Alternate exterior. Why do they use the word alternate there? They alternate sides over the transversal. And why are they exterior? Outside of the parallel lines. That's a good response. The next one is consecutive interior. It tells you that, but why do they use the word consecutive? What's that mean? Means same side. You might want to write that down. Same side of the transversal. Consecutive means same side of the transversal. Why do they say interior? Inside of the parallel lines. Good. All right, I can guarantee problems like this on the test, so please focus. I know some of you struggle a little bit with algebra, so make sure to practice here. First thing you need to do is read the question. Find the value of x. Doesn't say find the size of the angle, just the value of x. So first off, we need to locate these angles and figure out, are they the same size or are they different? They're the same size. So write that out. This is what you should be thinking every time. Are they the same or are they different? They're the same size. They are both acute or obtuse. Both obtuse. Whenever they're the same, they're going to equal each other. So this is basically the equation, the format we're going to be plugging into. The 113 is the same as the 3x minus 4, so they're equal to each other. We can write it in the equation. And now we can solve. What's the first step of solving this two-step equation? Good job, add 4. Last step. And then x is, I don't know that one off the top of my head, you'll have to help out. So we get 39 is what I heard. Good job. And this next one's a pretty practical example. It should make sense to you. It says a taxiway is being constructed that intersects two parallel runways. So they're talking about an airport. You know that angle number 2 is 98 degrees. I would definitely write that in there. Right angle 2 is 98. So this one is 98 degrees. What is the measure of angle 1 and how do you know? First off, what words match up with their positions? Alternate interior. They switch over the transversal and they're inside the parallel lines. Those are alternate interior angles. And what do we know about alternate interior angles? They are the same. They are the same size. So measure of angle 1 is going to be how big? 98 degrees. Try this checkpoint. It matches up with the previous example we did. And then you can try the checkpoint below that. So here are the checkpoints you need to be trying. All right, so number 2 is the most commonly missed problem on this section and on the test because people don't pay attention. Earlier I said, are the angles the same size or are they different? You need to write this down. Earlier, when they were the same size, what was their little equation? They equal each other. That's pretty simple. When they're the same, they equal each other. But when they're different, they can't equal each other. It doesn't make sense. Over here, this is obtuse and this one's acute. Can they be the same size? It's impossible. So we have a few other choices. I usually have a poster on the wall that indicates our choices. What other formula would make sense in this case. They add to 180. The two separate ones add to 180. So here's what it looks like. Blank plus blank equals 180. That's what we're going to substitute into. That's not hard. We've done this before. So 3x minus 7 is the first blank, and x plus 5 can go in the second blank. They add to 180. We've done these. Unfortunately, some people struggle in solving these. What's my first step? Combine like terms on the left side, which is also known as simplify. So the like terms are the negative 7 and the positive 5. When you combine those on the same side, you actually do the operations they say. Minus 7 plus 5. You actually type those in exactly how they're written. You don't do any opposites. So minus 2. I also have some x terms that are the same. When they're on the same side, you actually use the signs they give. You do not do opposites. 3x's plus 1x is 4x's. Now it's a two-step equation that you should be able to ace. What step is first? Perfect. Divide by 4. There's our final answer. We found the value of x, which is what it says in the question. This next one says, in example 3, suppose angle 3 is consecutive interior with angle 2. What's the measure of angle 3? So I can go back and look at that one. So that's up here. It says, suppose angle 3 is consecutive interior. That's right over here. There's angle 3. Well, are these going to be the same size if they're consecutive interior? I'll exaggerate this example a little bit. This is exaggerated. There's angle 2, there's angle 3. Are they the same size? Definitely never going to be the same size if they're consecutive interior unless they're all 90s. So when they're not the same size, they are different. What's our formula for that? We just wrote it down. Blank plus blank is 180. Well, we know one of these. We know angle 2 is 98, and angle 3 is the other one. Subtract 98 and we get 82 degrees. Consecutive interior, you need to note this. Consecutive interior will be different. They're going to add up to 180. Consecutive interior are going to add up to 180. They're the oddballs. Most of the others are the same size, other than this right here. But does this situation have a name? Is there a name for this position right here? They're both inside the parallel lines? Nope, so it's not alternate interior, it's not consecutive interior. Are they corresponding? Are they alternate exterior? So this doesn't actually have a name. That's why we had to think logically, are they the same size or not, and go from there.